Jupiter, the largest planet in our solar system, is more than just a swirling giant of gas and storms. It is Earth's silent protector, a cosmic shield against annihilation. With a mass 318 times greater than Earth and a volume so vast it could swallow every other planet in the solar system with room to spare, Jupiter's gravitational dominance shapes the fate of our celestial neighborhood. But its role goes beyond mere size. Scientists now believe that without Jupiter's immense pull, Earth might have been bombarded into oblivion by asteroids and comets, rendering life as we know it impossible. How does a planet made mostly of hydrogen and helium, a failed star that never ignited, act as our solar system's ultimate defense system? The answer lies in its violent past, its crushing gravity, and the way it redirects disaster away from our fragile world. Jupiter formed 4.5 billion years ago, just as the solar system was taking shape. It was the first planet to emerge from the primordial disk of dust and gas, its rapid growth fueled by an insatiable appetite for material. Unlike rocky planets like Earth, Jupiter never developed a solid surface. Instead, it became a churning sphere of liquid metallic hydrogen, racked by storms larger than continents and winds that scream at 400 miles per hour. Its most famous tempest, the Great Red Spot, has raged for at least 200 years, a hurricane so vast that Earth could fit inside it 3 times over. But Jupiter's true power isn't just in its storms, it's in its gravity, a force so strong that it bends the paths of incoming comets and asteroids, acting as a celestial vacuum cleaner for the inner solar system. The first undeniable proof of Jupiter's protective role came in 1994, when the shattered remains of comet Shoemaker-Levy 9 slammed into its atmosphere. Astronomers watched in awe as 21 comet fragments, some over a mile wide, struck Jupiter with the force of 300 million atomic bombs. The impacts left scars larger than Earth itself, dark smudges in Jupiter's clouds that lingered for months. If even one of those fragments had struck our planet, it would have triggered mass extinctions, global firestorms, and years of nuclear winter. Instead, Jupiter took the hit, just as it has countless times before. But Jupiter doesn't just passively absorb threats, it actively deflects them. Its gravity acts like a slingshot, either hurling dangerous objects out of the solar system or trapping them in its own orbit. Some researchers estimate that without Jupiter, Earth would suffer 1,000 times more catastrophic impacts. The evidence is mounting. Amateur astronomers routinely spot bright flashes in Jupiter's atmosphere, the telltale signs of asteroids and comets burning up before they can reach us. Yet Jupiter's protection comes at a cost. Its immense magnetic field, 20,000 times stronger than Earth's, creates a radiation belt so deadly it could fry a spacecraft in hours. Its moons, like volcanic Io and ice-covered Europa, endure constant bombardment from charged particles. But for Earth, Jupiter's violent nature is a blessing, a cosmic bodyguard that has, for billions of years, kept the worst of the solar system's chaos at bay. Jupiter's role as Earth's cosmic guardian represents one of the most fascinating dynamics in our solar system. This gas giant's immense gravitational influence has shaped the evolution of our planetary neighborhood in ways we're only beginning to understand. The story begins with Jupiter's formation approximately 4.5 billion years ago, when it emerged as the first and largest planet in our nascent solar system. Its rapid growth created a gravitational behemoth that would forever alter the trajectory of countless celestial objects. Jupiter's composition, primarily hydrogen and helium with possible rocky elements at its core, gives it a mass 2.5 times greater than all other planets combined. This tremendous bulk creates a gravitational force so powerful it can deflect or capture incoming comets and asteroids that might otherwise threaten the inner solar system, including Earth. The protective mechanism Jupiter provides operates through several physical principles. Its enormous gravity well acts as a cosmic vacuum cleaner, drawing in potentially hazardous objects that venture too close. When comets or asteroids approach Jupiter, they face three possible fates: being slingshot out of the solar system entirely, captured into orbit around Jupiter, or pulled into catastrophic collision with the gas giant itself. This phenomenon was spectacularly demonstrated in 1994 when fragments of comet Shoemaker-Levy 9 collided with Jupiter in what became the most observed astronomical event of its time. The impacts released energy equivalent to millions of nuclear weapons, leaving visible scars in Jupiter's atmosphere that persisted for months. This event provided concrete evidence of Jupiter's role in shielding Earth from similar catastrophic impacts. Beyond simply attracting dangerous objects, Jupiter's gravitational influence helps maintain stability in the asteroid belt between Mars and Jupiter. Without Jupiter's presence, the orbits of these asteroids would become more chaotic and unstable, significantly increasing the likelihood of Earth-impacting events. Computer simulations suggest the impact rate on Earth could be 1,000 times higher without Jupiter's moderating influence. The gas giant's gravity creates orbital resonances that either clear out certain regions of space or maintain asteroids in stable orbits, effectively creating a protective barrier for the inner solar system. This dynamic has likely been operating for billions of years, potentially creating the stable environment necessary for life to develop and evolve on Earth.
Jupiter's protective role extends beyond just physical impacts. The planet's powerful magnetosphere, the largest structure in the solar system, interacts with the solar wind in ways that may benefit Earth. This magnetic field extends up to 2 million miles toward the Sun and tapers into a magneto-tail extending more than 600 million miles behind Jupiter, far beyond Saturn's orbit. While the full implications aren't yet understood, some researchers speculate this enormous magnetic bubble may help modulate the flow of high-energy cosmic particles through our solar system. The charged particles trapped in Jupiter's radiation belts are accelerated to nearly the speed of light, creating intense electromagnetic phenomena that can be detected from Earth with simple radio equipment. The study of Jupiter's protective mechanisms has taken on new urgency in recent decades as we've become more aware of existential threats from space. Modern detection systems have revealed that Jupiter experiences significant impacts far more frequently than previously believed. Amateur astronomers regularly observe bright flashes in Jupiter's atmosphere, the telltale signs of asteroid or comet impacts. In 2009, an impact scar the size of the Pacific Ocean appeared in Jupiter's southern hemisphere, created by an object estimated to be between 1,600 and 4,900 feet in diameter. More recently, in 2021, a bright flash detected by Brazilian astronomers was determined to be caused by a 1,000-foot-wide asteroid exploding in Jupiter's upper atmosphere with the force of 2 megatons of TNT. These ongoing impacts provide valuable data for planetary defense researchers. By studying how Jupiter's atmosphere responds to different types of impacts, scientists can better model what might happen if similar objects struck Earth. The 1994 Shoemaker-Levy 9 impacts, for example, revealed that large comet fragments can penetrate much deeper into a gas giant's atmosphere than previously theorized, with implications for how energy is transferred during such events. The dark impact scars that persisted for months showed how particulate matter behaves in planetary atmospheres following major collisions, information relevant to understanding potential nuclear winter scenarios on Earth.
Jupiter's protective role isn't absolute, however. Some objects still manage to reach the inner solar system despite Jupiter's influence. The Chelyabinsk meteor that exploded over Russia in 2013 with 30 times the energy of the Hiroshima atomic bomb demonstrated that Earth remains vulnerable. Near-Earth object tracking programs have identified thousands of asteroids whose orbits could potentially bring them close to Earth, with new discoveries occurring regularly. This reality has led to increased interest in developing planetary defense systems, with Jupiter serving as both a model and a warning. The gas giant shows us both the protective benefits of a massive planetary body and the limitations of relying solely on natural defenses. The relationship between Jupiter and Earth extends back to the earliest days of our solar system. During the period of late heavy bombardment, approximately 4 billion years ago, Jupiter's migration through the solar system may have played a crucial role in shaping Earth's environment. Some theories suggest Jupiter's gravitational perturbations scattered icy bodies from the outer solar system inward, potentially delivering water to the young Earth. At the same time, Jupiter's gravity may have cleared out many would-be impactors that could have made Earth's surface permanently uninhabitable. This delicate balance between delivery of vital materials and protection from destructive impacts may have been crucial for the development of life on our planet. Modern spacecraft missions have revolutionized our understanding of Jupiter's protective role. NASA's Juno mission, which entered orbit around Jupiter in 2016, has provided unprecedented insights into Jupiter's interior structure, magnetic field, and atmospheric dynamics. By mapping Jupiter's gravitational and magnetic fields in exquisite detail, Juno has helped scientists understand how the planet's internal dynamics generate its massive magnetosphere. The spacecraft's microwave radiometer has peered deep into Jupiter's atmosphere, revealing complex weather systems extending hundreds of miles below the visible cloud tops. These observations are helping researchers create more accurate models of how Jupiter interacts with incoming comets and asteroids. Jupiter's influence on Earth's safety extends to its collection of moons as well. The Galilean satellites, Io, Europa, Ganymede, and Callisto, serve as additional buffers, with their own gravitational fields contributing to Jupiter's protective network. These moons, particularly massive Ganymede, which is larger than Mercury, help stabilize Jupiter's system and contribute to its ability to capture or deflect incoming objects. Europa, with its likely subsurface ocean, represents another fascinating aspect of Jupiter's system, a potential habitat for life that exists within the protective bubble of Jupiter's magnetosphere, shielded from the worst of solar and cosmic radiation. The study of Jupiter's protective role has important implications for the search for life beyond our solar system. As astronomers discover exoplanetary systems, they're particularly interested in identifying Jupiter analogs, gas giants in similar positions relative to their stars, and smaller, rocky planets. These exojupiters may play similarly crucial roles in creating stable environments where life could potentially develop. The presence or absence of such protective giants could be a key factor in determining which exoplanets are most likely to harbor life. Our own Jupiter's history thus serves as a template for understanding planetary system architectures throughout the galaxy. Despite Jupiter's protective benefits, some scientists speculate that its influence hasn't always been entirely positive for Earth. During the early solar system, Jupiter's migration may have disrupted the asteroid belt, potentially increasing rather than decreasing the bombardment rate on the inner planets. Some models suggest Jupiter's gravitational perturbations could have prevented the formation of another planet between Mars and Jupiter, leaving the asteroid belt as a remnant of this disrupted formation. This complex history reminds us that Jupiter's relationship with Earth has likely evolved over billions of years, with its protective role becoming more pronounced as the solar system stabilized.
The ongoing monitoring of Jupiter's impacts provides crucial data for assessing the current threat level to Earth. By tracking how often Jupiter gets hit and by what size objects, astronomers can better estimate the frequency of potential Earth-impacting events. Current estimates suggest that Jupiter experiences impacts from objects large enough to cause global catastrophes on Earth about once every few decades. This relatively high frequency underscores how fortunate we are to have Jupiter as a gravitational shield. At the same time, it highlights the reality that some dangerous objects still make their way through Jupiter's defensive network to the inner solar system. Jupiter's protective role has become a focal point for planetary defense strategies. Some researchers have proposed that understanding Jupiter's gravitational dynamics could help develop future technologies to deflect asteroids away from Earth. Concepts include using gravitational tractors, spacecraft that would use their own modest gravity to gradually alter an asteroid's course, a natural process Jupiter performs on a massive scale. Other proposals suggest positioning artificial guardian satellites at strategic gravitational points in Earth's orbit that could help deflect incoming objects, mimicking Jupiter's protective function on a smaller scale. The study of Jupiter's atmosphere following impacts also provides insights into Earth's own atmospheric response to large impacts. The persistence of impact scars in Jupiter's upper atmosphere, sometimes visible for months, demonstrates how particulate matter behaves in planetary atmospheres following major collisions. This has direct relevance to understanding potential impact winter scenarios on Earth, where dust and debris from a large impact could significantly alter our climate. Jupiter serves as a natural laboratory for studying these phenomena at scales impossible to recreate on Earth. As we continue to explore Jupiter and its system, each new discovery provides deeper insights into its role as Earth's protector. Future missions, like the European Space Agency's JUICE, Jupiter Icy Moons Explorer, and NASA's Europa Clipper, will further illuminate the complex dynamics of the Jovian system. These missions may reveal additional ways Jupiter influences the safety and development of the inner solar system, potentially uncovering new protective mechanisms we haven't yet imagined. With every new piece of data, we gain a better understanding of our place in the cosmic order and how much we owe to our giant, turbulent neighbor.
Our planet is more complex than a simple guardian dynamic. The gas giant's immense gravity creates both protective and destabilizing effects across the solar system. On one hand, Jupiter acts as a gravitational sink, capturing or deflecting dangerous comets and asteroids. On the other, its influence can occasionally redirect objects toward the inner solar system, a reminder that its protection is not absolute. modern observations reveal Jupiter's ongoing defensive role. Since 2010, astronomers have documented at least 7 significant impacts on Jupiter, including the 2009 collision that left a scar the size of the Pacific Ocean. These events demonstrate Jupiter's continued function as the solar system's primary impact buffer, intercepting objects that could otherwise threaten Earth. Statistical models suggest Jupiter experiences major impacts every 1 to 2 years, with countless smaller events going undetected. Each represents a potential civilization-ending catastrophe that Earth has avoided thanks to Jupiter's gravitational dominance. However, Jupiter's protection has limits. The Chelyabinsk meteor of 2013, a mere 20-meter-wide object, exploded with 30 times the energy of the Hiroshima bomb, injuring over 1,000 people. This event proved that smaller objects can slip through Jupiter's defensive network, emphasizing the need for complementary planetary defense strategies. Current estimates suggest Jupiter intercepts about 90% of potential Earth-impacting objects from the outer solar system, but the remaining 10% still pose significant risks. The study of exoplanetary systems provides crucial context for Jupiter's importance. Many hot Jupiter exoplanets, gas giants that migrated inward, appear to have disrupted their systems, often leaving no habitable worlds behind. Our solar system's architecture, with Jupiter remaining in the outer system, appears relatively rare. This suggests Jupiter's specific migration history may have been crucial in allowing Earth to form and survive in the habitable zone. Looking ahead, Jupiter will continue shaping Earth's safety in complex ways. While it will keep intercepting many impactors, its gravity can also gradually nudge some objects toward Earth over astronomical timescales. This dual nature informs modern planetary defense strategies, including gravitational tractor concepts inspired by Jupiter's natural redirecting ability. Upcoming missions like Europa Clipper will further reveal how Jupiter's magnetic field and radiation environment affect its moons, and by extension, how its protective bubble operates. Ultimately, Jupiter serves as both a shield and a reminder of cosmic vulnerability. Its protection has been invaluable, but not infallible. As we develop more robust planetary defense systems, we must balance appreciation for Jupiter's natural safeguards with proactive measures to address the threats it cannot stop. The gas giant's example teaches us that planetary protection is an ongoing process, one humanity must continue studying and supplementing to ensure our long-term survival in an unpredictable cosmic environment.